This is the machine that my company builds. It is a desktop CNC mill. This was developed for DARPA for education purposes, but now we've taken it pro and put it out into the world. You can cut pieces in whatever material you'd like, aluminum, plastic, things like that, circuit boards, and you can do it with 25 micron accuracy. This is also really important. So you've heard a lot about 3D printers probably, but this is the real deal. So being able to print with resin, where you shine a laser into resin and that hardens a material, you can get now the resolution that you need to do medical research, you need to do to make crowns and bridges and also jewelry. These tools are now available. The next one is the laser cutter. So if you're doing 2D cutting and you have a craft business, or you're wanting to prototype packaging, or you're wanting to prototype in wood, or things that are typically hard to have manufactured for you, you also need a laser cutter. To cut big things, like big pieces of wood, big pieces of metal, you're probably going to need a router if you're going to cut those things. And the last one is finally the quick and dirty, the 3D printer that you've all seen. The difference between this 3D printer and the old one is, or the previous one that I talked about, was this one prints with a filament. So you heat up a plastic, deposit layers. Most of us have seen that. It's still valuable, even if you're doing high resolution work. Sometimes you just want to spit out a print really quickly. So all of these machines, you add them all less, it's less than 20 grand. And with that, I can have a garage which allows me to innovate very quickly in hardware. And so just like we saw with software, where people got access to code, people could build websites without asking for permission, and the world kind of got Zuckerberged by these people who came out of nowhere and built these big businesses. The same exact thing is going to happen with hardware, and it's going to happen with these tools, because now they're good enough that they can produce something where you can't tell the difference, whether it was built by a large company or in somebody else's garage. And I think this is really important because it means that people right now are building things that they need, and they're delivering them directly to the people that need them also. And they don't have to build very small quantities of these things. And I think it's really transformational where everybody can have a say. They can look at the world around them, they can see the problems that exist, and now they actually have the tools to innovate those solutions. So the last thing I want to leave you with is a question about education, actually, because my origins were with DARPA, building these machines for an educational program to put these manufacturing tools in the classroom. And I really want to know the answer of, is it worth it to spend 40 grand a year going to college? Or is it better to spend 20 grand and spend 4 years in your garage building a business and innovating in hardware and accelerating the rate of research in biotech? And I think that's an open question, but I would love for us to all think about that, because I hope that we choose to prepare this next generation of people to take on the level of innovation in hardware that we've seen in software over the past 10 years. So thank you.
Okay.